The Planet Pioneers STEM Starter Challenge is a fast paced, highly creative activity set on the distant and mysterious world of Neptune. While the setting is playful and imaginative, the core project is grounded in real world problem solving. Students take on the role of space travelers tasked with building a new colony in an unfamiliar environment. Each challenge card presents a unique mission. Some teams might design a shelter to protect their colony from extreme conditions, while others might be building an all terrain vehicle to explore the landscape or transport materials. As teams work through their individual challenges, each piece contributes to a larger shared goal, and together a full Neptune colony begins to take shape. Along the way, students are introduced to key STEM concepts, including simple machines and habitat design. They explore how structures function, how movement can be created, and how design choices support survival in a new and unfamiliar environment. One thing that makes this project particularly powerful is its wide range of accessibility. It has a low barrier to entry, so all students can jump in and start building right away, while still offering endless opportunities for creativity, problem solving, and deeper design thinking. Some of the tasks might include constructing a simple machine, while others are more static models. So feel free to distribute the tasks or divide the teams based on student-specific skill levels. Like all of the challenges in the STEM Starters card deck, this project can be completed in one class period. It's ideal for grades 3 through 12, but can easily be adapted for younger students. Core materials include the 3DuxDesign Go Box Classroom, drafting materials, and assorted crafts when available. There is an optional extension activity on the Neptune Colony project that introduces simple circuits and motion. Students can design a moving bot that must stay within the safety of the colony, combining creativity with early engineering and design thinking. To prepare for this activity, distribute one sheet of 3DuxDesign cardboard, or approximately 30 to 40 shapes of cardboard, and a handful of connectors for each team's use. Provide drafting materials and one task card per team, starting out face down. Begin the project by reading the mission guide card and then have teams flip over their individual task cards and begin the project. Allow approximately 25 minutes for the building and the design process. Then allow a few moments for each team to bring their project to a central area to complete the entire Neptune colony, and a few moments for each team to do their presentations. At the end, allow about 5 minutes for cleanup. If you plan on doing the extension activity as well, your Build-A-Bot accessory set has everything you need. This part of the project should take under 30 minutes, including a brief discussion about circuits, engineering, testing, iterating, and then some group discussion. The key to understanding why the bots move is in the design of the motor. After distributing the parts, ask your students what they notice about the motor. Students might notice that the tip is not a perfect circle, but it's more like a half cylinder. As the motor spins, this uneven shape creates an unbalanced force. This is called a centripetal force. And because the mass is uneven, it causes the motor to vibrate. Students may feel this by briefly holding the motor in one hand and placing one lead on each side of the battery. When the circuit is complete, the motor will begin to buzz or jump, and students will feel that. When the motor is attached to a piece of cardboard, that vibration transfers to the structure. And this is what causes the cardboard bot, or the alien in this case, to move. The movement will vary based on the design. A horizontally positioned motor may result in more of a forward movement, and a vertically positioned motor may cause the spinning or circular motion. Students may also observe that the forces also affect the movement. Friction and center of both play a role. These can be adjusted through design choices, such as adding more friction on one side with a pipe cleaner or additional connectors, or shifting the weight to change the direction. To build the circuit, students can use the stickers to attach both the motor and the battery to the cardboard. They can begin by placing two stickers on the cardboard piece. Then they can position the motor on one sticker and the battery on another. Keep in mind that the leads do need to reach either end of the battery. Once the leads are attached to either end of the battery, they can be secured with another sticker, and the students will instantly notice that the cardboard is now vibrating or moving. Unlike an LED light, the motor will actually work as long as the circuit is complete, so the direction may change based on a positive or negative placement of the lead, but either way, the bot will move. Here's a nice video done by students that does help to highlight some of the ways that you and your students can get your bot to move in different directions.
Hi, we're the 3Dux interns, and welcome back to Things You Should Know When Making a Build-A-Bot. This is tip number 4, friction. So when we are building our Build-A-Bot, our motors are oscillating. Therefore, our Build-A-Bot is going to spin in a circle. And in order to avoid this and have our Build-A-Bot to spin in a straight line, we want to change the center of gravity of our Build-A-Bot. And we can do this by adding friction to the lagging side. So what we do is we like to take some pipe cleaners, cut them in half, and the cardboard has a side where you can just kind of stick it right into the side, and it can drag on the floor, creating friction. If that's not enough friction, you can also set up guardrails. We've just made these using some 2 rectangular pieces of cardboard and 4 3-way connectors. And we set these up on either side, and then our little pipe cleaners act as arms, and they guide our Build-A-Bot through on a path, therefore hoping our Build-A-Bot will go straight.
Once students are done with their builds, have each team bring their projects to a central table, which will become the home of the Neptune colony. Invite teams to give a 1 to 2 minute explanation of what they built, its purpose, and any special feature or function. After all teams have shared, take a moment to observe the full colony together and discuss how the designs work together and what improvements might be made. There are a number of different ways that you can extend the Neptune Colony project to create a cross-curricular learning experience. For a nice literacy extension, have each team create a script for a commercial inviting visitors to come to the Neptune Colony for a family vacation. In this example of a different project, students used a combination of green screen, Chatterpix, and iMovie to create this Groundhog Day presentation.
Legend has it that on Groundhog Day, I will emerge from my burrow, and if I see my own shadow, that means there will be 6 more weeks of winter, and I'll go back to sleep for a bit.
Or maybe each team of students can describe their own structure, and you can use Book Creator to create a complete tour of the entire Neptune colony. Another really fun tech extension might be to have your students use stop motion and create a short video. You can add a math component by having your students use the Duxit ruler from their kits to measure each structure. For younger students, you can focus on things like measuring the perimeter or the area of the different shapes. For older students, you can extend this by exploring scale. Ask your students to determine whether their structures are built at a consistent scale. For example, one team might have made a rover that is 1/12 scale, while another team may have built the nursery at 1/24 scale. Students can use real-world measurements to compare their models to each other. This helps students understand and get a deeper explanation of what scale, proportion, and 3D modeling concepts look like when real architects and urban designers make models in the real world. However you choose to use the 3DuxDesign STEM Starter Challenges, you and your students are in for a highly engaging, playful, and low-prep STEM challenge that'll be perfect for the classroom, STEM lab, or even as a team STEM night challenge that the whole family can enjoy.